We're going to continue looking at angles and arcs within circles, and this time we're going to look at angles and arcs that are formed with different parts of a circle. So those parts that we're looking at are our chord, secants, and tangents. When we're looking at our chord, secants, and tangents, we have three different possibilities. We have them intersecting inside our circle, we have it lying on the circle, and then the third option is lying outside of the circle. So those are our types of angles that we're dealing with. So we're going to take each part on its own. We're going to start with the intersection on the inside of our circle. When we have a circle with it being crossed in the middle, so the intersection is inside that circle, we're going to be able to find the measure of the angles using these different formulas. So with this, what we're really saying is we're going to add the two arcs that are formed with that angle. So if we're looking at angle 1, it would be AD and arc BC. So we're going to add the measure of those arcs together and cut it in half in order to get our angle. Same thing with number 2. In this case, we would add arc AB and arc DC together, and then we're going to cut it in half to get that angle measure. First example for number 1, we want to find the measure of angle AED. In order to find AED, I need the two arcs that are opposite it. So I have AD is 45 degrees and BC is 109. I'm adding those together and then cutting it in half to get my angle measure. So when we do that, we get that our angle is 77 degrees. For number 2, we're looking for angle STR. In order to find STR, we need arcs PQ, which they gave us as 186, and then SR, which they gave us as 112. We're adding those together and cutting it in half in order to find our angle, and we find that our angle is 149 degrees. Number 5, we are looking at finding the arc measure of CDE. I see that they gave us my angle and they gave us the other arc. So they gave us GF. We're going to be able to set up an equation in order to find what our arc is, and I'm going to call that X for my equation. When we write that out, we're going to say that our angle is equal to 1/2, and then I'm going to add the two arcs together. I know one is 73 and the other is what I'm calling X. And when I solve for that, we find that X is 183 degrees. So that's for our arc measure. Number 6, we're also finding an arc. So we're finding QT. I see that they gave me 79 degrees for angle QUR. I know that 79 and the other missing angle, SUR, are supplementary, so that's why I have 101 written in there, because I subtracted 79 from 180. Getting that angle allows me to find my arc that I want to find. So I need to make sure that I'm using the correct angle with the correct arcs. The one that I want to find is what I'm going to call X again, and when I set up my equation, we have 101, that angle measure, is equal to 1/2 the sum of my arcs, so X is 95. When we solve for X, we get that X is 107 degrees. So those were the angles and arcs that were formed with our interior intersection. Now we're going to look at having that intersection on the circle. So we're going to look at a picture up here, and the angles that are formed are 1 and 2. When I look at finding that space or that angle, I am going to just cut my arc measure in half. So if I'm looking at angle 1, the arc that goes with it is AB. I'm just going to cut it in half to get that angle measure. For 2, I would be looking at ACB, so the rest of the circle for that other angle. And then again, just cutting it in half. If we look at our examples for this, number 7, I'm looking for the measure of the angle DEG. You can see that I drew that arc in there. They told me my arc measure is 308, so I'm going to cut that in half to get my angle measure. And when I do that, I get 154 degrees. For number 8, we're also finding an angle measure, so we're finding DBC. Before I can find the angle measure, I needed to find the rest of my arc. So they told me that arc BED was 192. I can subtract that from 360, the entire degrees for the circle, and find that the other arc, DB, would be 168 degrees. I can now take that and cut it in half to find the angle is 84 degrees. Number 9 and 10 are looking at finding the arc measure now. So for number 9, they told me that the angle is 151 degrees, and I want to find the arc XY. So I'm finding that little arc over here. In order to do that, I need the arc measure for the rest of the circle. So I can find the arc XZY by doing double 151, which is 302, and then I can subtract 302 from 360. When I subtract that, I find that the measure is 58 degrees. We're finding the measure of our KNM. So in order to find KNM, I need to figure out what that angle is. I got 157 by taking away 23. 23 is referring to that small angle there, JKM, and I'm subtracting that from 180. Once I have my angle, I can double my angle to get my arc. So when I double my angle, I find that the major arc KNM is 314 degrees. So we're following that rule for our intersections on the circle. The last way we can look at is our exterior intersections. So when we're looking at those exterior intersections, we can have it formed with two secants, one secant and one tangent, or two tangents. Either way, we're going to follow the same process when we do this. We're going to subtract the arcs. So we're going to do the larger arc minus the smaller arc, and then we're going to cut that in half in order to find our angle measure. When we look at number 11, if we're trying to find KLM, that little angle down here, they gave me my two arcs. I'm subtracting that, and then I'm going to cut it in half. So I'm going to do 140 minus 66 and cut that in half to find that angle KLM is 37 degrees. For number 12, angle BCD, again, that little one up in there, we have to subtract those arc measures. In order to subtract the arc measures, I did need to first figure out what that little arc BD was. AE, ED, and BD all add together to be 180 degrees. So I subtracted 67 and 94 to get 19. Once we do that, we're going to subtract those arcs, and then we're going to cut that in half to find that our angle is 24 degrees. Looking at a couple more exterior intersection problems. Number 17, we're finding the arc of EF now. Before we can find the arc of EF, I do need to figure out the arc of FH. In order to find the arc of FH, I can call that X, and I can use the angle and the other arc and set up my equation. When we do that, we have our angle of 77 is equal to 1/2, and then the arc subtracted from one another, so 191 minus X, and I solve for X to be 37. Now that I know EH and I know HF, I can subtract those two from 360 to get that EF is 132 degrees. Number 18 for MK, we are going to find our X, so we're going to set up our equation. They gave us the angle and the other arc. So I have 156 equals 1/2 160 minus X, and X equals 48 degrees. For number 19, we're finding angle PQR. So PQR, I'm still subtracting those arc measures. 313 is PSR, so I can subtract that from 360 to find that PR is 47. And when I subtract those, I'm going to cut it in half to find that the angle is 133 degrees. For number 20, for the measure of CDE, I again can subtract one of the arcs from 360 to find that the other arc is 254. And then when I subtract those and cut it in half, I find that my angle is 74 degrees. So those were our examples with our exterior intersections. Again, with exterior intersections, we are subtracting those arc measures and cutting it in half to find our angle. When we have our intersection on the circle, we just need to cut that arc measure in half. And then for our intersections inside the circle, we're adding those arc measures together before cutting it in half. So if we can remember those, we'll be able to find those arc and angle measures inside our circle.